Department of Electronics and Communication Engineering at BIET Jhansi. Sir has been contributing his work through various research in his main interest being sensor design for agriculture applications. So without further ado, I request respected sir to take the lead of the program and share his knowledge and experiences with us all.
Thank you so much for introduction. It is a great pleasure and honor to be with all of you in 3 days training program on IoT applications in agriculture, sponsored by Chaudhary Charan Singh National Institute of Agriculture Marketing, and that is NIAM, which is a research and higher educational institute operating under Ministry of Agriculture and Farmers for the welfare of India. The training program is organized by Rajsthan Technical University Kota at the venue where you all are attending in offline mode at Modi Institute of Technology Kota. (14 to 16 March 2024). I have come to know that the program is organized in very short period of time. Therefore, I heartily congratulate to all the organizing team. I would like to appreciate the great inspiration and motivational thoughts behind the whole university, Professor S.K. Singh, Honourable Vice Chancellor, Rajasthan Technical University, Kota, and Mr. Shushil Modi Ji, Vice Chairman, MIT Kota. Great appreciation and congratulations to Professor Vikas Soni Ji, Principal MIT Kota, and Ravishankar Gayal Ji from NIAM for actively organizing such a wonderful training in short period of time. Dr. D.K. Palwalia Ji and Dr. Deepak Bhatia Ji for inviting me over email and giving me the opportunity to be part of this workshop. I hope this will be fruitful and very informative to all of you to create some unforgettable memories and impressions for the future. Agriculture is an essential sector needed for survival of the human community. Several measures have been taken to enhance the crop production. However, harsh environmental conditions and frequent pest infestation led to agricultural loss. In such scenario, integration of advanced technologies such as advanced sensor coupled with Internet of Things could escalate the agricultural production and minimize the economic loss. Studies have been conducted across the world that satisfactorily demonstrated the implications of integrated IoT smart sensors in monitoring environmental factors such as moisture, humidity, temperature, soil composition that are very critical for the crop growth. Greenhouse gases like carbon dioxide, methane, etc. are measured through automated sensors nowadays. Smart farming is very popular and it is enabling the measurement of nitrogen content in the soil and helping farmers to determine the number of and the quantity of fertilizer to be used so that they can improve their quality of the production. Some latest IoT enabled equipments and unmanned aerial vehicles are useful in accurate surveillance of pest attack and associated disease in farm vegetation. Though the smart farming has a great scope in the future and present days, it faces certain limitations such as high implementation cost, data security, and lack of sufficient digital knowledge in farmers. Special economic policies, data encryption policies, and digital literacy is being implemented among the farmers so that we can ease this IoT enabled smart farming in the future. We know that smart farming is also known as agricultural precise agriculture and digital farming. It is using modern technologies and data analysis techniques to optimize the agricultural products or agricultural production. It integrates various technologies such as the sensors, GPS, drone, artificial intelligence, robots to monitor and manage crops. The sensors and IoT devices are deployed in the fields to monitor various parameters such as soil moisture, soil temperature, soil humidity, and soil nutrient levels. This data coming out of these sensors helping the farmers to make informed decisions about irrigation timings, fertilization timings, and controlling the pests that are destroying the farms. Also, the data coming out of these sensors are being used by advanced analytics and machine learning algorithms, artificial intelligence tools to process the data collected from the sensors to provide insights and predictions. Farmers can use this information to optimize planting schedules, irrigation schedules, predicting crop yields, and identifying potential problems before they escalate. Nowadays, remote sensing is being done with the help of drones and satellite imagery for and aerial surveys of the agricultural land. This provides us detailed mapping of the agricultural lands and analysis of the crop health, water stress levels, and pest infestations in the fields. Actually, the remote sensing is also enabling us to define the targeted actions and how can I minimize the input. Robotics are also playing an important role in this. Robotics and autonomous vehicles are increasingly used in the agriculture nowadays, so that the tasks like planting, harvesting, weed control are being controlled so that labor cost is reducing and efficiency of the farming is improving, so that round clock operations can be performed. Automated irrigation systems are using the real-time data to deliver the right amount of water directly to root of the plant. They are not wasting time, the water, they are optimizing the water use and minimizing the water wastage and maximizing the crop yield, so that watering only to the root or not for the entire crop. And also we can optimize the supply chain completely, like by using the blockchain technologies that are coming nowadays, and this way we can ensure the food safety of the supply chain and reducing the fraud coming in the supply chain, so that the pure food reaches to the consumers from the origin of the food. Very smart systems are being developed with the help of IoT and artificial intelligence, so that integrated platforms can be provided to the farmers so that they can do the actions according to the recommendations of the decision support systems on the real time. So that way the smart farming has a very big potential to revolutionize the agricultural system by making a sustainable, productive, resilient changes to so that they do not have to worry about the climate change and resource scarcity. Also, for this, the important barrier is the initial investment cost and the technical literacy and data privacy. So that also we have to improve. If we look on the architecture of the agricultural IoT, then we see the major parts of this are we can divide it into the subsections. Subsections are starting from sensors, then IoT platforms are required that include the main control board and the wireless communication technologies, are required, then cloud platforms are required for computation, and also overall, because all digital systems and electronic systems require the power and energy management, that is also required. Sensors for IoT, the proper selection of sensors of to an application is essential for IoT system developers as well as for users to best of the sensors. Low energy consumption, compatibility in data transmission between the microcontroller and sensor, accuracy, repeatability, sensitivity, robustness. These are the major considerations to select a proper sensor for IoT system development. Based on the literature review of the 200 different researchers, soil moisture sensors are being mostly used in this application. So it is the largest means mostly preferred sensor among all sensors of the agricultural system. After this, humidity sensor and air temperature sensor comes. The region these sensors were integrated most of the agricultural IoT systems so far is because of the need of the continuous in situ soil moisture monitoring for decision making in the irrigation system. Because the soil water tension is measured by soil water potential sensors only appeared in only three papers. So that is because of the less understanding of the relationship between the water tension and less soil water potential sensors, availability of the sensors, etc. Precision farming sensors and IoT devices are deployed in the field to monitor various parameters such as soil moisture, temperature, humidity, and nutrient levels. The data coming out of precision farming helps the farmers to make informed decisions about the irrigation timing, fertilization, quality, and pest control. Acoustic sensors in the IoT are also very popular because of their applications. Ultrasound distance measurement sensors and microphones. These are the two main sensors available for the acoustic property of this sensors. Direct use of acoustic measurement is limited in agriculture IoT. Hardwood borer. One work is published for the hardwood borer identification using the IoT sensor network. This is a very direct application of microphone in the pest detection of the forestry. Compared with the mechanical wind speed and direction sensor, an ultrasonic anemometer requires less maintenance due to fewer mechanical parts involved. Furthermore, an ultrasonic anemometer can capture sudden change in the wind speed and directions very accurately compared to the mechanical done. This ultrasonic wind speed and direction sensor called ultrasonic wind anemometer consists of 4 ultrasonic converters forming 2 measuring directions orthogonal to each other. The distance is approximately 20 cm. The converters function as a sonic transmitter as well as a sonic receiver, with the sort of measurement of sequence of single measurement starts in all 4 directions measuring distances. The measuring directions are done with the help of their angle. The setup of ultrasonic sensor can be seen in the picture given in this slide, and we can see that the time required for the forward movement is calculated by the distance between sensors divided by the velocity of sound plus velocity of the wind. When the wind is in the forward direction. If wind is in the backward direction, then we can calculate the time required is equal to t backward is equal to distance between the sensors divided by the velocity. By solving these two equations, we get the velocity equal to 1 upon time forward minus 1 upon time backward, and the velocity of the sound is equal to d by 2 1 upon t forward minus plus t backward. The directional components of velocity are calculated in both in x and y, and then total velocity is equal to v is equal to root over vx square plus vy square. Okay, and the direction is calculated by tan inverse vy upon vx. So that is the theta equal to tan inverse vy upon vx. In this way, the direction of the wind and the speed of the wind is calculated. The virtual temperature can also be estimated with the help of ultrasonic sensors only, because the speed of the sound is dependent on the temperature root function. It is a root function of the absolute temperature of the air. However, it is roughly independent of the atmospheric pressure and slightly depend on the dampness of the air. This temperature is called virtual temperature because it excludes the effect of moisture and dampness of the air. Signals are recorded, and after the recording, the processing is done. So, for the processing, we can use the processor. Before processor, we can use some digital filters, and filters can be FIR filter or IIR filter or some PID controller, Kanban filter, etc. So IoT enabled ultrasound distance sensors are widely used nowadays in irrigation systems to estimate the water volumes in the tank also, wells also, and reservoirs. So it is essential for irrigation scheduling and automatic irrigation systems. You can see that recently ultrasound flow meters are replaced the mechanical flow meters because of their high accuracy, rate of measurement, and etc. Ultrasound scanning of underwater is possible for aquatic plant growth monitoring purpose, such as lotus and seaweed. These has huge potential to determine the harvest stage and growth rate monitoring. Fruit ripeness estimation is a very interesting example of the acoustic sensor in agriculture. One work by Dao Swang in 2020 demonstrated that watermelon ripeness could be estimated by a sound generator and receiver. In summary, I can say that acoustic sensors advanced in recent years while replacing some traditional mechanical agricultural sensors and introducing new applications in the agriculture. Let us come to the biological sensors in the agriculture. So, the above ground biomass, plant height, plant leaf density, and plant age, chlorophyll concentration, stomata conductance. These are the biological parameters used in the crop monitoring. So this biomass estimation is done by the direct sensing techniques or some biological techniques. I am not very good in this biological things. So therefore, I don't know the how and what type of chemicals they use. They use some chemicals for the biological reactions and the color changing, or some microscopic view or calculation of these things. So this is a different one of the different area. I am not going to discuss in detail here. In addition to biomedical sensors, there are some chemical sensors also that are being used in the agriculture. So these chemical sensors can be of two types. One is photochemical sensor and another is electrochemical sensors. Photochemical sensors measure the chemical reactions or chemicals by their spectral nature, and electrochemical sensors measure the electrical properties. Because of the chemical reactions, the electrical properties change. So, and because of the presence of chemicals, some electrical properties change. So that change is measured and recorded. So the example of these sensors are pH sensors, salinity sensors, soil nutrient sensors like NPK sensor, oxygen sensor, carbon dioxide sensor, methane sensor, pH sensor, and photosynthesis, and the parameters are often measured by chemical sensors. So, if you know the pH of the water and soil, it is important because the pH affects the solubility of the nutrients and therefore the plant nutrient uptake and growth. The measurement of the real time nutrient of the soil, especially the nitrogen, phosphorus and potassium, it is very essential for fertigation. So these sensors are still in the development and R&D stage. So many people are improving the quality of these sensors. Although some of the manufacturers are branded nowadays, and they are providing the sensors, they are visible, they are means market in the market they are available, and we have in our lab IoT sensors lab, and that LoRaWAN enabled some NPK sensors in this IoT in our sensor IoT center, IoT Experience center. So it is very important and very useful also. The real-time soil nutrient sensing, it have a very huge potential in future agriculture and nutrient leaching and groundwater pollution. So these are the serious issues that nowadays being faced by the people or by the farmers. Nitrate sensors can be fixed to groundwater pumps to monitor the nitrate status of the groundwater, or these can be installed in the water and water collectors in the field to get reasonable estimation about nitrate leaching. So the soil salinity can be derived from the soil electrical conductivity, and it is demonstrated many times in the literature. This is very important parameter to measure the alkalinity or soil salinity, so that it is because it degrades the irrigated agriculture. Okay, so therefore the electrochemical sensors are very important and very useful. CO2 and methane are the greenhouse gases, and these are very responsible for the climate change and the agriculture associated with these two gases very closely. Therefore, their emission need to be measured. So, sourcing and sinking of the carbon dioxide and methane from the soil and crop is important so that we can understand the budget of greenhouse gases in agriculture. Research suggested that the elevation of the carbon dioxide can increase the crop yield and improve the water use efficiency. Therefore, essential to measure. Estimation is very nice, essential. Oxygen sensors are also to be used for the crop quality monitoring and crop yield monitoring. Electrochemical sensors can be useful to estimate the dissolved oxygens, increased dissolved oxygens. So chemical sensors improved rapidly in past decades. Applications developed based on them in agriculture are in the very early stage. So more research is required to improve the quality. Now let us come to the electronic sensors. The electronic sensors, after the advent of microprocessors and digital signal processors, now the electronics has become heart of everything. In every industry, either it may be the civil industry, it may be the chemical industry, it may be the communication industry, it may be the music, it can be computer, it can be medical, it can be astronomy, it can be environment, it can be control system, it can be anything, power system, it can be the microgrid, etc. Everywhere electronics is nowadays the heart of the system, the heart of the artificial intelligence. So the modern systems are being becoming intelligent because of the electronic sensors only. So they are dependent on the electronic hardware only. Electronic sensors play a key role, important role in agricultural IoT systems, and they are being used in many industries for long period. The main principle behind these is to measure the change of electrical properties due to physical or chemical change in the plants, soil and the environment. Some electrical parameters such as charge, current, potential difference, electric field, resistance or conductance or capacitance or inductance, some change will come in anything, any electrical property, so that the soil, for example, soil moisture sensors by IoT system, they are using the capacitance for their application. So these are very popular because the agricultural lands are facing water shortage and climate change nowadays. Therefore, electrical resistance, capacitance and permittivity of the soils are can be used to estimate the volumetric water content. So, how this can be done? This is done by the knowledge, by understanding that soil acts as a sponge to take up and retain the water. Movement of water into the soil is called infiltration, and downward movement of water within the soil is called percolation. So pore space in the soil is very important, and that allows water to infiltrate and percolate. It also serves as the storage compartment for the water. Presence of water content changes the permeability, which in turn can be converted to electrical quantity. Thus, the soil water tension was measured by electrical resistance of gypsum blocks. Further, the soil water tension was measured by electrical resistance of we have used some other blocks also instead of gypsum. For better irrigation scheduling, the soil water tension is very important. Also, the volumetric content is very important. And one example in the next slide will show you that how the water content can be measured. So this slide represents the capacitive equivalent. So first figure represents the lateral combination of the dielectrics. So in this way, the capacitances become the parallel combination of capacitance C1 and C2, and in parallel capacitors are added. And layered combination of two dielectric makes a series combination of capacitances C1 and C2. And if there is spherical combination, that is also a series combination of C1 and C2. This way, we can model the presence of soil in the capacitive sensor, and the effect of change in the capacitance because of the moisture can be modeled and can be studied. So there are four types of humidity sensors: acoustic sensors, capacitive sensor, resistive and thermal. These sensors are very useful. Sensors can be developed to measure the absolute, relative and specific humidity. For example, the grain harvesting is highly dependent on grain moisture content, and if harvested without considering the optimal moisture level, it may cause extensive post-harvesting damage and economic loss. Therefore, this measurement of moisture in the grains is very important. Now, rain sensors in the agriculture are also very useful, and they are based on the electrical conductivity principles. It is an electronic sensor, and it can be connected to IoT also, so that it starts working when there is a rain between two electrodes. Optical sensors are also very useful in the agriculture. So they have a key role in modern agriculture or precise farming or smart farming. There should be a light source and an optical sensor like camera to take the measurement to start. Ultraviolet sensors, visual sensors and near infrared sensors are the main wavelength regions where the optical sensors are operated. It is important to note that optical sensors appear to have the least applications IoT sensors, but they are very good for processing the data. Typical RGB images captured from the optical sensors are used to derive the vegetation indexes for the agriculture, which are very useful to calculate the yield of the crop. So there are two vegetation indexes. One is normalized difference vegetation index, another is RADS NDVI, normalized difference vegetation index. Okay, so naturally the signals in the visible regions are used to indicate the many crops, many parameters such as maturation time, crop yield, crop nutrient requirement, paste pressure, as well as water and nutrient level in the soil. Historically, people used to see the crop by their eyes and evaluate the qualitatively. The introduction of these sensors has significantly improved the measurement of the crop and environmental parameters, extending the spectral regions from visible only to ultraviolet and near infrared. Fruit spectral signature has been used to identify the ripeness of the fruit, and so that it can be harvested on time. Nowadays, artificial intelligence is one of the fastest growing technologies in the modern world. So, AI is very extensively being employed in the various industries, now especially in the agriculture industry. It enables us to the satellite imaging, landscape mapping, and climate change monitoring. So the AI mediated automation sensors in the agricultures have the good quality products with less negative impacts on environment. AI with smart sensors has led to the development of an advanced technology known as Internet of Things, and nowadays everything or all the sensors are being connected to the IoT, and IoT is connected to AI. So therefore, AI has become very important. Now I will show you one example of my that I have developed for the processing the sensor vision sensor or optical sensor data and identifying the soil quality. So computer vision based farm soil identification has been done in this MATLAB program. So I will execute the MATLAB program, open the MATLAB and execute this program. So you can see it here, and after execution you can see that this is giving you the kind of first of all we have to select an image, and image is being processed, and after processing it will show you the type of the clay or type of the soil that image is having, and the accuracy of this here in the 500 iterations you can see it is showing it is 93%. Okay, so thank you so much to you all for being with me, and thank you so much. I'm stopping here.